Hey guys, welcome back to another webinar. So let's see, where are you all joining from? Hello, can see it in the chat. Ariel, hello. Anand, Pablo, Christian, Vikas, hello there. Adriana, hello. Turkey, Italy, US, Switzerland, awesome. Germany, but from Chile. Saudi, España, Barcelona, Kenya. Wow, from Kenya. Taiwan, Poland. Awesome guys. Thank you very much for joining in. All right, so let's just get started. So first things first, you go to your email and you check the download files. Okay, you will find it in the email, a link to the download folder. So I hope you all have been able to download the zip files. Okay, let me know if anyone is having any difficulty. You can just register it one more time and you will receive an email where you will have that link to download it. Okay, awesome. Another thing, just confirm me if you're able to hear me properly, if you want me to increase my volume. Okay, you can write it on the chat. Perfect. Thank you very much for confirming. Some people are asking if this will be available to watch it again. Yes, of course. You can use the same YouTube link to watch it after the webinar finishes. Okay? Perfect. All right, so if you have downloaded the zip file, let's get started. So first of all, thank you very much for joining in, especially on weekend, on Sunday. We really appreciate it. So in this webinar, we are gonna be modeling the Logitech vertical lift ergonomic mouse. Okay, you must have seen the posts. That's why you guys are here, basically. If you are not aware, we have already done a couple of webinars in the past, so you can go to the resource section and you can see this was the first webinar. So if someone who's barely starting with Rhino, you might find this one a bit more useful to start with. And of course, the second webinar was a bit more complex geometry. This was the third webinar for a VR headset. And now we are on the fourth webinar. Okay. So the webinars have the common theme of creating a workflow. So you start by modeling your geometry in Rhino. Then you will apply textures in Grasshopper. And finally, we will export it so that we can render in Keyshot. Okay. You can, of course, download the free version of all of these softwares from their respective web pages. All right. So how will the workflow look like? So we will start by 3D modeling the mouse in Rhino. You will also notice that I have prepared the file in such a way that you can follow along the steps, and you will also understand how you can create such complex shape from complete scratch, right? Also keep in mind that it might be a bit more difficult to follow along, so try to skip steps because I have prepared files or shapes in that particular section that you can try and copy to learn that specific command. Okay, so we will start by creating the curves, then we will move to surfaces, then we will add details with the Boolean operation, and finally we will prepare the mouse for texturing in Grasshopper. In Grasshopper, we will import that surface and apply, in this case, a triangular panel texture on the grip area. And finally, we will export the overall geometry to Keyshot for rendering. Okay, so everyone's ready. You can just write me if you have been able to download the files. That would be awesome. Okay. Wow, so you guys are joining from almost all around the world. Arjun prefers to say Earth. Sure. Maybe in future we will have Martians joining in. All right, awesome. Again, I'm insisting, don't stress too much. Try to follow through. The webinar is recorded. You can watch it again so that you can step by step follow through later on. Perfect. So let's start Rhinoceros first. Okay, so I have already turned it on. So this is what Rhino looks like. So if you're complete beginners, it's gonna be a bit more difficult, but try to follow along in any case. So in the 4 viewports, the first thing that we will do before we open the file is that we will turn on the package manager. Okay, so you go to the command bar and you write package manager. Okay, if it's in Spanish or other language, you can always write underscore and then the command in English. Okay, it will work that way as well. And basically the package manager is a new way to install the plugins in Rhino and Grasshopper. Okay, so in our case, we will be downloading the Lunchbox plugin. So you can look for Lunchbox and you can find that plugin here. Just press install and there you go. So you don't have to go to the Food for Rhino page, download the zip file, copy it in the components folder, etc., etc. All the plugins are not here yet, so most common plugins you will find here. So just try to download it through package manager. Okay. Yeah, some of people are asking where can they get the files. You need to first register it on our webpage, cademy.xyz. Let me just show you. Okay, you can just click on the webinar 4, fill up the form, and you should receive the zip file link. Okay, so once you have installed the Lunchbox plugin, let's get started with the files. Okay, so when you download the file, you will have this zip file. Let's unzip it. All right, so you can see it's a pretty heavy file, 152 megabytes. That's because the textures sometimes they weigh a lot. I'll give you some tricks to reduce the weight later on. So as you can see, I have broken the workflow webinar into a couple of steps. So the first step is Rhino. The second step is texturing Grasshopper. The third step is basically preparing the file in Rhino so that you can import it in Keyshot. The fourth step is importing the file in Keyshot, and the fifth step is just experimentation with Keyshot rendering environment. All right. I also have step 0 where you can find the reference images if you would like to start from really from scratch. Okay, but I have already incrusted the images in the Rhino file. Okay, so shall we start? What if it's not showing package manager? Package manager should be visible in Rhino 7. Can't find Lunchbox on Mac, failed to fetch packages. So all the problems that you are having, let me see if we have some time towards the end, I can help you out. But if not, you can find a way to resolve it after the webinar and try to follow through. And of course, the Lunchbox thing is only for the Grasshopper step, okay? But the rest of the steps, you can open the file and you can follow along. All right, perfect. Great. Also, thanks. I think, who's he? Ruta? No, Max. Someone told me. Jess. Yeah, how to download it. Thanks for that. All right, so let's open the Rhino file. You can drag and drop it. Open the file. Okay, there we go. So these are the steps that we have to follow in order to achieve the final result. So first things first, let's change the viewport to shaded. Okay, and you might notice that it's taking a bit longer, and the reason for that is I have cleared the mesh cache so that it doesn't weigh a lot when you're downloading the file. Anyways, so now you can see the first step is basically going to be creating the curves and the basic surfaces. Second step is going to be creating the top part of the mouse. The third will be adding details with Boolean operation, and finally texture with Grasshopper. Let me see if anyone has any question. All right, so apart from that, you can also look in the layers tab, and you will see that I have broken the steps into different phases. Okay, this is the overview. You have reference images, then you have base, and so on. Okay. All right, someone else is asking, hey, will this be recorded? Yes, it will be recorded, don't worry. All right, so let's finally get started. If you want to start from scratch, you will be dragging and dropping the images. So let's say the bottom image first, and you will import it as a picture and deposit it here. Okay, you can go to the top view and you can scale the image more or less of the same size as the reference drawing. So you just take one of the measurement, which is 108 millimeters, go to the scale tool, select the object, scale from here till there, and it should measure, I think it's 108 millimeters. Okay, and you can see now the image length of the mouse from top to bottom is 108 millimeters. Okay, and you would basically put it in the center, and you would do the same thing with the rest of the images. And finally, you can also reduce the opacity of the image so that you can draw on top of it and still see the curves. Okay, you can change it under property object, materials, and change the transparency. Well, for the webinar, I have already prepared the images. So when you turn on the reference image layer, okay, you can see that I have put all the different viewports, okay, that you can use to create the mouse. So let's start with the first step, the base step. Okay, and you will notice that you have two parts of the workflow. The top part is the part which I have already finished, and the bottom part is where I would encourage you to follow along the steps that we are seeing. Okay, so let's get started. I'm going to go to the top view, and the first step is basically drawing the outline of the mouse. Okay, so you can draw the organic shape that you see here using a curve through control points, and the degree of the curve is a degree 3 curve so that we can create a smooth curve. A degree 2 curve is not so smooth, and basically a degree 1 curve is like a polyline. Okay, so we are going to use a degree 3 curve for this shape. So let's turn it on, set the degree to 3, and then you just copy the shape, okay, the outermost shape. Okay, you don't have to be too precise at the moment, because once you draw the points, we can always come back and recalibrate the outline. Okay, so there you go. You can just move these control points manually. When you select the curve and you don't see the control points, you have to turn it on over here, turn on the control point of the object, and then you can move it left and right accordingly. Okay, So once you have drawn the outline of the mouse, I have left it here prepared. The next step is going to be creating the internal curve. Okay, so for the internal curve, you just use the same curve, basically Control C, Control V, and you scale it. Okay, you scale it. So you scale it by using the gumball. Okay, if you don't see this tool that shows the arrow, you have to turn it on at the bottom of your Rhino viewport, right? Gumball. All right, so I'm gonna scale it in this axis as well as this axis. So just try to make it as close as possible to this outline. Okay, and you can see just by scaling it in the two direction, we are able to copy that shape. All right, so once we have the two curves, now it's time to draw the cut that we have to apply on this shape. Okay, so let's go to the front viewport around here, and I'm going to draw this diagonal cut. So let's turn on the curve through control points and try to mimic the shape of this cut. Okay, you can of course turn on the control point. You can move this control point in order to calibrate properly the shape. All right, so once you have done that, the next step is going to be creating this curve that will define the lateral profile. So in order to do that, what you have to basically do is, once you have created this curve, okay, let's just move it a bit behind, we have to extrude it. Okay, so you can use this curve and you have to extrude it. All right, so in order to extrude a curve, you can of course first run the command, which is surface extrude curve straight, and you just extrude it beyond the base curves so that we can project it later on. Or you can also use just the gumball, and using the green handle, when you drag it from the green handle, you are extruding that geometry. Okay, and finally, we don't want this surface that we have extruded to have this much control point, as well as we also want to dip the surface in the front part. So I will be changing the properties of the surface, and you do that by rebuilding the surface. Okay, so you select the surface, you run the command rebuild. Okay, and I have given you the properties to rebuild the surface, so you're gonna rebuild it using degree 3 in U direction. So the red arrow is the U direction, and degree 2 in the V direction, which is the green arrow. Okay, so you will have 4 control points in this direction, 3 on the other. So you set it to 4 and 3. These are a bit more complex topics. If you're starting with NURBS modeling, it's basically the smoothness of surface in, or the degree complexity of the surface in the two directions. And you have to just add one more point than the degree to have a single span surface, which is like a really smooth surface. Okay, but don't worry about it at the moment. Just try to copy this part, the parameters, and press OK. So you can see now that we have slightly changed the property of the surface. And what we will do is basically move this part down by 15 units. Okay, -15, and this part by -1. Okay, that's what I have mentioned here. That's because if you look at the reference image, that's how much the part dips in the front part. If you compare, this is the back part, that is the front part, so we have to move it around 15 units down. Okay, and lastly, we have to now project this curve on this surface. So let's run the project command. Project curve to the surface. and you should see the curve projected on this curved surface. Okay, let's see if someone has any question. Can you please explain rebuild a bit more, when to use, etc.? How can I turn the units next to the mouse on? Rebuild is basically that once you have created a geometry, you can change its degree and number of control points when you rebuild it. Okay, generally you would use it when you have a really complex shape and you want to smooth it out or simplify it, or when you have a specific dimension curve but you have to create a single surface out of it. You would rebuild it with a lot of control points so that you can create a single surface from those many control points, and then you can apply some texturing techniques to it. How can I turn on the units next to the mouse? You can do that by going to document properties, going to mouse, I think, mouse, then you have mouse, oh no, sorry, modeling aids. It's under modeling aids, cursor tooltip, and turn on the distance option. Okay, so once you have, let me repeat the project command, project the curve to the surface. Okay, that's how you will get it. Make sure that the project direction is up so that it projects up, not front or back. And finally, once you have the projected curve, that's one of the use of rebuild. So you can see the curve is really complex. So whenever I create a surface from that curve, it will also be that complex. So what I can do is I can rebuild it using fewer control points. Let's say maybe 11 control points. Okay, so now this geometry is a lot simpler and smoother compared to the previous surface. Okay, and finally, if you look at from the front view, you can see that the control points are either up or down because this was a curved surface. So what we can also do is we can make sure that all the points are aligned in the same plane. So you can run the align command and make it to fit the average plane. So did you see slide modification? Align to fit plane. Okay, there you go. And finally, we are gonna prepare it for the blend surface part. So first, you have to create a surface on the bottom curve. So you can just generate the surface by going to planar surface option. There you go. Then we're going to extrude this curve upwards so that we can now blend these two parts. And one last thing that we will do before performing the blend, because let me show you what will happen if we just blend it right away. It is working, but we need to add some additional profiles to align the cross section. Okay, so let me first generate the profiles and then I will perform the blend operation. So in order to create the profiles, what you can do is basically go to the top view, which is around here for that geometry, and you would run the bounding box command. It's going to draw a curve, a rectangle around that curve, and you can basically find the intersection and draw a line. Here you find the intersection, draw the line for the 4 parts. Okay, and once you have drawn the line, you would basically extrude the line up. Okay, make sure that this is intersecting with all the shapes like that. Okay, you can also move it a bit behind, bit forward, bit outwards on either direction. So what we are trying to achieve here is basically intersect this with this shape so that we get that specific place where we have to create the cross-sectional profile. So you can come here where I have already prepared it. Just run the intersect command. Select the geometries that you would like to intersect. And you will notice that it has created these intersection curves, right? Which we can take advantage of when we are performing the blend operation. We also don't need to see these ISO curves. A lot of you probably model in SolidWorks or Fusion. So these programs have their ISO curves hidden by default. So you can also do that in Rhino. Select the objects, go to the object property and hide the ISO curves. Okay, so now you don't see those additional curves within the surface. And finally, let's perform the blend between these two edges. So you will run the blend surface command, where you will blend this edge with this other edge. Okay, and we need to align first the seam where the surface will close on itself. So I'm gonna use this cross section. Okay, and let's press OK. And you will see that this command asks you to define different continuity criteria, as well as you can control the extension of that continuity. So in this case, if you set this to 1, it's basically like a simple loft. If you set it to tangency, then you can see it's following tangency on this part, and it's continuous, positionally continuous, or G0 continuous on the other end. So it's G0, G1, G2, G3, G4. So these are different continuity criteria. And you can choose which edge has which of these continuity criteria. So in this case, we need G0 for 2. We don't need any kind of continuity except positional for the bottom part. And for the top part, we are good with G1. The only thing that I will change here is the extension. So it's going to be, I think it's going to be 0.5. You can define it like that. And finally, you will add shapes, because you can see these internal ISO curves are not aligned to our profiles. So let me add new shapes. Again, you can do that by drawing a line going from here till there. And you can see it helped align the cross-sectional profile. Same goes for this to that part. And finally, from this part to that part. And there you have the bottom surface. You can always hide the ISO curves if you want. And finally, you can also rebuild it using less number of control points to simplify the surface. So I have given you the criteria to rebuild it here. So degree 3, we are gonna rebuild it using 20 control points in U and 4 control points in V. So you can see this is now a simpler surface compared to the previous surface. This was previous, this is after the rebuild. Okay, you will always try to work with simpler surfaces. So that's basically the first shape. Any question? What's the difference between just blend and then the intersect step? So if you just do normal blend, the both command will work exactly the same, but if you have created the intersection, you will add additional shapes that can help align the ISO curves. If you don't do the intersection, you don't have that reference so that you can align it properly. Okay, that is why we had to align first the intersection and then perform the blend. So let's go to the next step. I'm gonna try to go a bit faster now. So the next step is basically creating the top part. So the top part of the mouse is made like this. You create like a curve, you pipe it around 10 units of radius, and then you intersect it with a plane. Okay, so if you intersect this, you get that curve for the top part. That's basically what we have to do. So in this case, you can see that I have basically drawn two curves approximating the front and the back part, thinking of it as a cross section of the pipe. So the radius is 10 units. And I have connected the centers of these two shapes, or these two circles. Okay, you can try to do it on your own. You can create a circle with a radius of 10 units. Okay, once you do that, you will project these geometries to these two planes. Why? Because if you look at from the top view, you can see that is where the cross section or the circular part of the pipe starts on both sides. So I can just extend it, and then I will project these shapes from the front view to these two planes, right? Like that. And finally, you can create a loft between these two curves and connect a line between point 1 and point 2. So this is going to help you define the angle in which you have to draw the pipe. Okay, so the next step is basically going to the top view and trying to follow the shape. So let's try to follow the shape more or less like this. Okay, I think it's better to draw it on the floor like that. You can extend it later on. And finally, you will project the curve on the shape. Okay, just keep in mind that when you're calibrating something, you can project it with this option called record history. So turn on the record history, and then when you project it on the surface, you will notice that when I move this thing, that curve automatically adapts to the new position. So this is like a really small parametric option that you have in Rhino. And lastly, you would create a copy of that plane and move it up by 7.5 units. I have done the calculations earlier, so that is why you're just moving it in that way. And finally, you will pipe the curve. Okay, make sure that when you pipe the curve, the cap is set to round, so that the starting and the end of the pipe has a round cap. Okay. When you rebuild the surface, how do you ensure that it doesn't break continuity with other surface? You cannot. You have to match it again. So you cannot guarantee. Of course, you can add a lot of control point more than the neighboring surface. That way you assure it. But apart from that, you have to match it one more time. And lastly, we are going to intersect this tube and the plane to get that profile. Okay, that's basically the profile that we have here. And finally, you can split the tube with this profile. You can get rid of the bottom part, and there you go. So we have modeled the top part of the mouse. Okay. Now, the next step is going to be about creating the profiles for the surface generation. So the easiest way to do that is just extending this plane so that it intersects with the bottom part. Okay, and you can do that by finding the radius. Okay, and there's this option called mark radius. So let's click that, and you can see it creates this circle. So that circle is a planar circle, and you can convert it into a surface, right? And with the shift key, you can extend it as so much as that intersects with the base surface. Right, so in that way we can now create a curve that is on this plane. So it's a lot easier for us to later on create the surface. So I will do that for the front and back part, and finally I will intersect them. Intersect this and this. Right, so you can see that we have these intersection curves. Okay, and lastly we have to create the profile. So you can either do it by two steps. You can either use the blend option. So let me go to the shaded view. You run the blend, not surface, but blend curve, where you blend, let's say, this green curve to that curve. Okay, and you can define the continuity criteria. So in 1 we want position, and in 2 we want tangency, and you can drag this down to match the curvature of the surface. Okay, that is one way. Another way of doing it is just draw a line between this point. It's gonna be a bit easier in perspective mode, and that point, and you would rebuild it using 4 control points in this case, and then moving these points to match the outline of the mouse. Okay, so these are the two different ways to generate the curves. So once you have these curves, we can now generate the surface. So let's turn on this next layer. Let's go to this part. How do you know break the continuity with rebuild? When you rebuild, let's say, for example, some of you have the same question. Let me copy this. So when you rebuild a surface, you cannot guarantee that it's gonna maintain the continuity. So for example here, if I rebuild it with some, let's say, 16 number of control points, you can see that I have broken the history or continuity between these two objects. Okay, so you cannot guarantee it. So what you will do is you will recreate the boundary. So planar surface, and I will recreate it. Okay, so you cannot ensure that it's gonna be continuous. Another thing that you can do is you can try to match surface, match this edge with this edge, and you can define whether you want to match it with position, continuity, tangency, or curvature. You can also refine the match so that it matches perfectly within the tolerance of your file. So those are only two options. Anyways, let's continue. So this part, let's generate these surface. So for the surface, we will be creating it using sweep to rails. So let's go to sweep to rails. Rail 1 is our edge at the bottom. Rail 2 is the red curve. And then you can select the cross-sectional profiles. And basically you can see we are generating the surface. Okay, make sure that you turn on the closed sweep option so that it closes the sweep. Okay, and press OK. So that's how you will generate the surface. You can go to rendered viewport if you want to see it under HDRI. And you can also hide the ISO curve if you want. Okay, so the next step is going to be rebuilding the surface. Again, we are going to rebuild it. It's going to go away from the original edge. So I will show you how you can resolve that problem. But the reason for rebuilding it is, see this surface, it's really complicated surface. It's not smooth. Also, if you run commands like analysis, surface curvature analysis, you can see there are so many artifacts on this surface. Okay, so what you will do is rebuild it with as few number of control points as possible without losing the shape of the surface. So in this case, you can change the degree to 5 to have even smoother surface and change this one to 36. Okay, so that is basically here. And lastly, you can also analyze the surface. So generally the Gaussian analysis is basically when the surface either folds inwards or outwards. You can resolve that by turning on the control points, and you can manually move these points to kind of relax the surface, but you're moving the points in the coordinate of Rhino. However, there is a special tool called Move UVN, which can help you move a point on the UV or normal direction. You can also smooth it out by the smoothing option. So you can select the point and you can smooth out that point. So this can slowly help you create simpler and cleaner surface. Okay. All right. You can do that for the other parts. And finally, you will end up with something that looks like this. And of course, the edges, they don't match. I cannot just magically join them because when I rebuild it, the edges are not coincident anymore. So what you do when you have to join these two parts together, well, you create a buffer area between these two parts. And you can do that by basically taking the curve. Okay, here you can see how I have done it. You basically take the curve and you rebuild it like every time with a lot of control points. Okay, and then you pipe it. Okay, so the surface that it generates is a lot smoother. So you can see I have already created the curve here. You can pipe it, or you can first pipe it and you can also rebuild the pipe if you want. Okay, both will work. So once you have created the pipe and rebuild it, you would just trim these two surfaces with the pipe so that you can get rid of some part from the top part and some from the bottom. Right, so once you have done that, you can now blend these two surfaces, just like the previous example. Select the edges, define the continuity criteria. In this case, you can define curvature, and you can keep on adding more cross sections. Right, so I'm helping Rhino understand how it should create the blend. Okay, so finally you will end up with this, and you can join it with the rest of the shape. Okay, you will also notice that it doesn't leave any naked edge on the top part, of course. And you would do the same for the bottom part. So as you can see here, I have the curve. If you want, you can rebuild it. You would pipe it just like last time. Rebuild the pipe if you want even better effect. And then you would split these two shapes with the pipe. Delete this part and you blend these two surfaces. Chain edges. In this case, G1 is more than enough. And if you want, you can help Rhino with the cross-sectional profiles. Okay, so once you have done that, why must the pipe be rebuilt? So when you are creating the pipe after you have duplicated the edge, you will see that the pipe, the pipe has some complex shapes. If you turn on the control points, you can see it here. But if I rebuild it one more time, it's gonna try to relax those sharp corners. Okay. And finally, yeah, you would have the final geometry. You can hide the iso curves, and there we have the final shape. Now it's time to add the details. So let me hide this and turn on the fourth layer. Yes, so to smoothen out the surface of the pipe, you rebuild it. All right. A lot of times you will see that the screen is a bit lagging behind, and that is because I have cleared the mesh cache I told you earlier, and that is why it's recalculating every time I'm trying to see it. So it might take a bit while for you as well. So the next step is basically hollowing the structure. Okay, and the easiest way to do it is just duplicate the edge. Okay, and you basically scale it, and you can move it down by 1 unit. Okay, you convert it into surface. Yeah, so if it doesn't create a surface, you can always follow the same technique where you select the control points, align to fit plane. So it will do really minor modification to put everything in the same plane. So once you do that, you can then create a surface. I have the surface here, and then you can do Boolean split. So you end up with two different solids. Okay. And finally, once you have those two shapes separated, you can then hollow the solid shape. So for hollowing, you will use the shell command. Okay, shell. Which face you would like to remove? Let's say this face. And you define the thickness, let's say 2 millimeters of wall. Press OK, and you can see that it has created another solid with a 2 millimeter thick wall and then empty space. Okay. So in this example, I have tested it. Shelling up to 1 millimeter works. This command will not always work, so for 1 millimeter you can see it works. It's going to take a bit longer for the top part. Okay. What if you wanted to keep the sharp edges? The pipe blend surface seems to work best when you want smooth transition. In the other case, you would probably rebuild with higher number of control points and match the surfaces using the match surface command. So as you can see, once we shell the geometry, you can end up with two solid poly surfaces. And after that, I have also given you another way of creating it. So imagine if your thickness is higher than 2 millimeters. Okay, and in that case, it's not going to be easy to shell the shape. So for that, you would basically explode the geometry and join the rest back. Okay, let me move it a bit below. Yeah, and then you will offset the surface, both sides, give a bit more tolerance, solid no, rounded corners, and distance, let's say 2 millimeters. So it's going to create an internal offset, of course not creating a solid. Let me flip it so that you can see it easily. Flip the surface, and of course you can see there are some artifacts. You need to get rid of them. Just delete them like that. Yeah. So once you have this part cleaned up, you can just select the edge with Control Shift click, and you can drag it down to extrude it. Okay, let me join it back. I can move it up by 25 units. So I need to trim this plane with this and this with this plane, both together. So trim this with this. Okay, so you can see I'm able to get rid of this part, and then trim this with the internal plane. So basically we join them together and we end up with a solid shape. Okay, when shelling command doesn't work. The next step is generating the profile for closing the mechanism. You can go to the front view, go to the wireframe viewport, and then you just draw a profile. You can use the command like profile around curve. Sorry, rectangle around curve, around this curve. Again, you can draw a rectangle of whatever size you want. You can move it in. In this case, I'm gonna make sure that it's within the geometry so that later on it's easy to sweep and remove the excess part. So you can see here I have left you the profile. So you just go and run the sweep with one rail. This is the rail, this is the cross section. Press OK, press OK. And you will notice that the profile is inclining as the profile as the cross section revolves around the profile, but you can force the profile to maintain a specific orientation. So you convert it into a road-like sweep, and the axis in which it has to orient itself is the z-axis. And now you can see this was before, this is after. It has oriented it perpendicular to the z-axis. Okay, and you would repeat the same for the bottom part, and you will end up with these two sweeps. So here what you can do, let me just change the color so that you can see it in different viewport. Split this, or I can just do Boolean difference, this with this. Okay, and you can delete this part as well as that part. So this is the lid part that is left that you can join together with Boolean operation as a single solid. You would do the same for the bottom part, but here you have to remove the material. You can also leave a bit of tolerance. So if you check on this profile, I have extended it a bit beyond that so that it eats up a bit more material for the tolerance. Remove it with this. Right, so you can see here that we have the lid part. Okay, and finally that's basically our final shape. We are left with just two more things quickly. How to add the grooves. It's gonna take a bit longer. Are you guys able to more or less understand till this part? Let me know if you are having difficulty or if you have any other questions. In order to create the grooves, let's get close to that part. Okay, you just draw these lines. So you can probably start by drawing a straight line and then rotating it in a specific degree. Okay. So here I'm just going to create a line that is closely resembling to this part. Okay, so that I can intersect it with the geometry later on. Okay, I will do the similar thing but for the side view. So it's going to be a bit difficult to visualize the side view because we have a lot of geometries in between, but let me just show you how it will look by moving it up in the right view. Okay, so here I need to generate this shape. So I'll create a line that passes through that part around here, and another line that passes through that part around here. Okay, when you generally draw in Rhino, the curves will be all the way in 0, 0, 0 of Rhino. Okay, so be careful with that. And now you can see I can also extend this and create an intersection between the mouse and the geometry. So you can copy this part, okay, and you can intersect the mouse plane, other plane, and you will see that it has given us all the intersections that we will need to create the groups. Okay, let me delete the planes. Okay, apart from that, we also need to create a groove just below this blend. Okay, so in order to create a curve here, you can first duplicate the edge to get a curve exactly on the edge, right? And after that, there is a really interesting tool that lets you offset a curve but on top of a surface. So what we can do is go to curve, offset, offset on surface. Select the surface, and you can see that the curve will be now offsetted on top of the surface automatically. So you can see that the curve is existing on top of the surface. Okay, how did you extrude with gumball? In Rhino, when you see when you have Rhino 6 or 7, you will see this circular handle. So when you drag it from that circular handle, you can extrude it. So a point can be extruded into a curve can be extruded into surface, a surface can be extruded into poly surface. Okay, and lastly, you have to just clean and trim. So select everything, just get rid of this part, on the other side, this part, and this part. Okay, rest all we can just delete. So select everything except this, and you can delete it. Right, so there we go. We have now this path where we can then pipe and create the groups. Lastly, we will also add a fillet. So you will see that I cannot just add a fillet on this non-planar curve. Okay, so the easiest way to do that is by creating a sphere of the radius that you want, let's say radius of 2, and you can intersect the sphere with the curves. It's going to give you these points, and you can use the points to split the curves into small parts. Get rid of that, and now we can just blend it. Blend curve. Okay, G1 continuity, and there you have a fillet on the corner of exactly that dimension. Of course, once you do the fillet, you will have to pull the curve back to the surface. You will run the pull command. Pull the curve back to the surface. Okay, because when you do the blend, it might not exactly be on top of the surface. And lastly, we are going to create the diagonal. So let's go here, let's create a line that passes through the center. Okay, and just extrude it and intersect this and this. Okay, and you can again split this curve using this curve, so you can get rid of the extra parts. Perfect. Yeah, so finally that's what we have at the end. Let's turn on the wheel layer, and we will perform the pipe and Boolean difference in the next step. So for the wheel, you basically take the same diagonal profile, okay, and you move it here. And the wheel is approximately a cylinder of 12 millimeters of radius, and you can apply a fillet of 4 millimeters to the corners. Okay, and then what we will do is align this object on this plane, or orient it. So you can run the orient command, select the object from here to here, orients from here to there. And the only thing we need to do is use the reference image to position it around that part. Okay, so now we know where the wheel should be. One thing I didn't mention before, like all the objects are separated by 150 units. So when you move it 150 units, you will see it exactly goes to that specific part. Alright, so the last thing is basically creating an intersection between the wheel and the surface. So you get that profile, change the color, and if you want to create an offset, just like last time, curve offset on surface, and you change the height to be, let's say, 2 units. Sorry, curve offset on surface, not normal to surface. Flip and define the distance. Right, so that's basically how you can get the additional part so that you can split it out, and then you can convert it into solid. Surface, offset surface, solid yes, give it the thickness, both side yes, and there you go. So now you can use this for Boolean difference. And that's how you will end up with this geometry. Lastly, you will also be creating a pipe. I'm not sure what was the radius, but maybe around 0.4. And you would do Boolean difference with the pipe. When the wheel move part was a bit fast, can you maybe... Okay, sure, I can explain it to you one more time. I used the orient command for that. Yeah, maybe here there's a slight problem with this. You can just pipe it one more time, but without the cap, flat. So maybe it's gonna work better now. I think I haven't created the hole. Yeah, it's not a solid geometry, that's why it's not working, but yeah, in this part it should work. Pipe. Okay. Anyway, so the orientation for this geometry was, let's say if you have any shape here and you want to orient it on this plane, you would run the orient command, object from this corner to that corner goes to this corner to that corner. Okay, so it orients it like that. Perfect. Alright, so once you have the final shapes, let's move on to the buttons part, the other side button. So you would also just draw the curve from the side view. Okay. So you will draw the curve from the side view this curve, okay, and you would basically extrude it and intersect it so that you can get this curve that you will use to generate the button. Okay, so here you can see I have created the button, and finally you will create another curve, pipe it to do Boolean difference to get the button part. Again, of course, here you have to do a pipe. I'm not sure what's the radius. 8 is too much. 4. Round cap. Something like that. Move it inwards, and there you have the button. Okay, and just like the wheel part, you will intersect this with the poly surface to get the profile. You will offset the profile, trim the surface, and then do the Boolean difference. All right, so last we are left with the grasshopper part. Okay, what's the time? Yeah, we have half an hour. All right, so first we have to prepare the geometry for grasshopper. So once you have the geometry, you will basically get rid of everything else except the part where we will apply the texture. Okay, you don't need this at the moment. So once you have the part separated, we need to find out where we have to cut this surface so that we can apply the texture. So the easiest way is to use the reference image, and we have to trim the surface around here and around there. So the easiest way to do this is extracting the ISO curve of the surface. Extract ISO curve. Select the surface. So the ISO curve is around here, and the other one is around here. If you see that the ISO curves are not in this direction, just try to toggle the direction from U to V. Okay, so a curve surface has infinite ISO curves, so you are just basically extracting one here and another one over here. So once you have extracted the ISO curves, we don't need these ones, you will split the surface on the ISO curve. Split surface with this ISO curve, with this one, and be careful, there is also a small part, so select that as well. You will notice that you are now end up with this small chunk of the surface. Okay, any part that was really confusing to you guys? Because now we have to move to grasshopper. Let me know any questions. The hexagonal textures, unfortunately not. We are going to be working just with the triangular texture at the moment. What if you wanted to keep the sharp edges, pipe blend? Okay, yeah, I think we have responded to that. Okay. All right, so if all good, then let's move to grasshopper. So let's turn on the grasshopper environment by clicking this button. Okay, it's gonna pop up this window, which is just the grasshopper window that's gonna float on top of Rhino, and this is where we will be creating the texture for this shape. Okay, if you want, you can also drag and drop the step 2 file in the grasshopper canvas. Okay, like that. So the first step is basically importing the surface inside grasshopper. So in order to do that, let's double click on the canvas and write surface. So it's going to create this different nodes. Okay, the one that we need is this hexagonal node, which is basically a geometry container. In this case, a surface container. Okay, so in order to reference this surface in Grasshopper, you have to right click, set one surface, and you will notice that Grasshopper window minimizes, and it's asking you to select which surface you would like to reference into Grasshopper. So there you go, we have imported the surface in Grasshopper. Now if you have installed the plugin correctly, you should be able to see this L tab, which is the Lunchbox tab. Okay, and in the Lunchbox tab we will be applying different panels. Okay, so in this case we are going to be applying triangular panels. Okay, let's create that component. Connect the surface to the surface input. Okay, you drag the cable, you connect it here. Okay, if you want to disconnect it, you can right click and disconnect as well. And if you don't want to see a node, you can select the node, press the middle mouse button and hide it. Okay, so now let me hide the geometry in Rhino as well. Let's go to wireframe. Yeah, wireframe is better. So I need to calibrate the number of panels I want in the horizontal and vertical direction. In this case, you can copy these numbers, 60 and 25. 60 in U and 25 in V. Okay, if you want higher density or lower density, you can change it. Okay. All right, so once you have created the triangular panels, you will notice that the panels extend beyond our surface. And the reason for that is our original surface is actually that big. Okay, what we have done in Rhino is trimmed the surface during different operations, so we only see this part, but the original surface extends all the way around, if you remember from the sweep and rebuild command. Now Lunchbox plugin works in this way. It will always generate the panels on the entire surface. Okay, now there is a quick way to get rid of the panels that we don't need, that are beyond the trimmed surface, and it's also going to help put the curves exactly on top of the surface, because at the moment they are not on top of the surface. Okay, so the command is called pull curve. It's going to pull the panels to the surface. Okay, let's connect it. It might take a while, but now you can see that the curves from the panels are now pulled to the surface. You can hide the triangular panel component, and you can see that we have the curves on top of the surface. Okay, any question till this part? Okay, no worries, let's continue. So the next part is basically cutting the surface on these curves. Okay, so in order to cut the surface on these curves in Rhino, you would do something like this, right? You have the curve. Let me create a copy of the surface. And you would do something like split the surface with these curves, right? and you will end up with these small chunks, right? So that's what we will do in Grasshopper. Just a moment, let it calculate the mesh. Okay, let's go back here. Okay, let me also extend it till this part so that we can see it properly. All right, so in order to split the surface, you will use the surface split component. You will always be able to see the name of the component as well as the logo. So you can just write the same name and you should be able to find that component. So we need to split this original surface on this set of curves. Okay, so seems like it worked. Takes a bit longer because it's a complex operation. Someone asked, can we align the beginning of the triangles to the beginning of the surface? For the trimmed surface, technically you can do it. What you can do is just move the original seam, the surface seam, somewhere else, and you will be able to control the position. So if I show you by untrimming the original surface, this is where the surface is closing on itself. So I can always run the surface seam command and move it anywhere I want. So that will be the starting of the panels. Okay, the only problem will be the other part. But if you can generate the panels and use the ISO curve and cut it exactly there, maybe you can get away with that. Someone asked, what if you ran shrink trim before bringing it to Lunchbox? You don't need to, but yeah, that would also help. You can run that. Just make sure that you have to calibrate the UNV amount one more time so that you don't generate a lot of panels on this part. And lastly, can you please explain the pull curve tool again? So yeah, whenever you create a surface and you want to put a curve on top of it, let's say it's a deformed surface, okay? And let's say you create a curve here and you want the curve to sit on top of the surface, so you can pull the curve to the surface. Okay, it's different than project because in this case you cannot project easily. Each curve is facing in different direction, so you need to find exact vector in which you have to project. But when you pull it, it just attracts it to the surface. Can you explain what if the surface was built from network curve? I don't think there should be any problem. You can still use Lunchbox with that. So the next step is basically in two parts. So the first part is separating from all of these small chunks, from all of these trimmed chunks, the ones that are really small. So what you can do is you can calculate the area of the surfaces. You will find that the component is red in color. Maybe there is some really small part that it's unable to calculate the area for, but it works even then, so you can ignore the error. So what we are going to do is we're going to measure whether the area is smaller than certain value. Okay, and using that criteria, I'm gonna separate the surfaces into two lists. Okay, let's hide this, hide these as well. So if I add a surface container here, right, you can see that these are the small chunks. And if I keep on increasing the number, It's a really big number. Okay. So as you can see here, we are able to select the smaller chunks like that. So I will set this to around 2.5 or 3 so that we don't create a panel texture on this part, but the rest part we can do. So these are the parts that will be joined to the final texture later on. Now we have to work with the rest. I can hide this. So for these parts, what I have to do is basically scale it. Okay. And you can scale the panels in the same place by using the area center. Okay. And you can change the factor to make the panels smaller or bigger. Okay. So these are the scaled panels, and these are the original panels. Now we need to move these scaled panels away from the surface. So you need to move it away from the surface. Now, in order to move any geometry, you need to provide a vector in Grasshopper. You need to tell how it should move. So by default, it's all moving upwards, but you have to move it in the normal direction. So you have to find the normal direction for each panel. Okay, and you can do that by using certain components like brep closest point, where you basically pull these centroid points on these surfaces, and it's going to give you a normal direction, and you can use the normal direction to move the panels in the normal direction. Okay, as you can see here. And if you want to control the height, you can just multiply the number with either a positive or a negative value. Yeah, it's sometimes acts weird. Grasshopper, maybe it's not understanding it as a vector. It's still working, but just that it doesn't give you any problem. I'm going to use the amplitude component, which is basically the same. Okay, perfect. Yeah, someone recently told Chris, correct. Perfect. So now we have the original patches, we have the base patches, we have the moved patches. So I need to first convert them into curves. You can just add a curve node, and Grasshopper translates the boundary of surfaces into curves, just like that. You would do the same thing with this part. Okay, and we need to loft the base curve and the target curve. So in order to do that, you have to know a bit more about data tree. So what we are basically doing here is putting each curve in a separate branch. Okay, so in order to do that, we just graft the data tree. And now you can see each curve is a new sublist. Okay, and you can see that the first curve in the base panel and the first curve in the target panel, they have the same address, which means when I fuse them together, they will create a single list with two curves inside. So now when I loft them together, it should work perfectly. doesn't work perfectly. Let's see why. Height is too much. Nope. Sometimes the data conversion doesn't work really well. Let's see. If I convert it into curve directly, neither. Let's see if I convert it into curve after that. Still some problems. Yeah, I think problem could be the way we are dividing the surface. In case it doesn't work, no worries. I have actually created at the bottom similar script. Yeah, probably it has to do something with one of these small parts. In this case, let me just grab this part. Okay. All right, so that's the base surface. Pull, split. Yeah, now I see. I'm using it twice, but anyways, we can continue from here. So here you can see it's basically the same workflow. And in this case, I'm also adding an attractor, which basically will control how much the curve extrudes outwards, okay, as it gets away from the boundary. Okay, and finally, you will end up with a single poly surface. Okay, if you want, you can check the file properly. Let's bake the result to convert it into a Rhino geometry and move it 150 units. How would you draft analysis? So in this particular example, we are not worried about that because we are going to be 3D printing it. But if you have to analyze the manufacturability of this, you would run the draft angle analysis. In this case, it's found here, draft angle. Let me set the direction. This way by curve. Okay. Add object. Is the tractor point the center of the referenced surface? So for first, you can see here where you might have issues with the draft angle. Okay, so here is a way to evaluate. Maybe you have to do it in 2 or 3 separate parts for this mold, for this particular texture. Okay, so someone asked, is the tractor point the center of the referenced surface? The center of the reference surface, yes. You attract the points to the curve and then you remap it so that you can move the patches of surface away in a controlled way. Okay, and the final result looks something like this. Okay, and finally you would move the texture 150 units. So in this case, what I have done is you would duplicate the edge, okay, of this surface, join it, and move it back 150 units. So you are basically putting the curve exactly from where we took it out, and you can split the poly surface with that curve. So you can get rid of this and substitute it with the texture. And hopefully when you join it, it should create a single solid poly surface. If you, Anand is asking, is there a way to blend the pattern to fade away smoothly in the main surface? Actually, the attractor thing that you see here is doing that part. It's just that it's not so obvious in the shaded or wireframe viewport. But if you go to rendered viewport, you can see that the corners are getting faded away. Okay. And you can check. Once I have joined it together, we should get a single solid poly surface, right? So we have taken a patch of the original surface, removed it, applied texture, cut out that part away, and replace it with the texture. Okay, so that's basically the final part. And lastly, you can also split the texture using a plane depending upon the curve, reference image, to create it into two separate parts. So Boolean split into two separate parts. Okay, any questions? I think the only issue here was that when we are splitting, it's creating some really small fragments, or maybe some of the fragments are invalid shapes, and that is why we are getting an error on this part. And yeah, that is why the next steps were not working well. But in this case, I don't know why it works. Maybe the separated part is moved to another list. But is it possible to blend patterns to G1 or G2 continuity right in GH? In Grasshopper, it's going to be a bit difficult to blend in such a way. Anyways, so let's move on to the last part about Keyshot. Okay, you can save the files. You can also export the objects separately, so you can export it in a layer, this one in another layer, and the buttons in another layer. Okay, do you have any detailed course on how to build logics in Grasshopper? Yeah, we will be talking about that towards the end. Just a moment. All right, so you will see that I have a third file. If you open it, you will see that I have basically separated the file in a new, the geometry in a new file. So you can see I have layer for the texture, for the base, top part, and the button and wheels. Okay, and basically we will be opening this in Keyshot. Okay, so let's open Keyshot. Okay, and we are going to open the file in Keyshot. Okay, the third file. Just make sure that when you import the NURBS data so that you can control later on the mesh tessellation. No worries, you can also try to follow along through Keyshot 7. Just import the Rhino file. So in this example, we will be creating a physical light studio, So the first thing that we need to do is apply a basic plastic material to all of these different objects. I mean, I have already applied it, so you can either rename it or you can apply a new plastic material that is white in color to all of these different parts. So this is the base, texture, top, and button and the wheels. Okay, you can also double click to edit. Let's say this is the texture, this is the top part, this is the button, and this is the base. So it's easy for us to later on differentiate. All right, so once we have the clay material set up, we're gonna beginner want to learn Rhino. Okay, I'll be talking about that just in a moment. So in order to render the mouse, let's first create a floor. Let's go to model, and let's add a simple plane. I'm gonna change the size of the frame. So you can go to position 100, maybe 1000. Okay, 1000 is better. Okay, and we're gonna create a render from the top view. Okay, so let's go to camera. You can define it manually, or you can just use a standard top view. Okay, that's the easiest. I will also change the lens perspectiveness to 200. Okay, so that we don't have that much distortion. So that's basically the camera setup. Okay, whenever you click here, you will see that camera. Finally, let's change the base color to white, and let's then add a plane that we will convert into a light source. Okay. First, you need to turn off your environment light. So you can see here. So you can go to Environment tab, Environment, and then you reduce the brightness to 0. Then you take the plane and convert it into an area light. Okay, you change the material type of the plane to an area light, and now you just have to orient it properly and of course calibrate the intensity. So let me rotate it 90 degrees and move it around here. Okay. All right. So once you have positioned the plane, there are a couple of things that we can do with this. Let me just put it here. First thing that we need to change is the power. So generally you should work with lumens, which is luminosity flux, and for a 100-watt light bulb it's around 1600. If you work with lux, the size of the panel or plane will determine the intensity, right? So with lumen it's a constant intensity, so that's a bit better and easier to configure. And you can control the shadow smoothness by changing the scale of the panel. So the bigger panel you have, the softer shadow you will get, and the smaller panel, sharp shadows. Okay. And lastly, if you want to rotate the light around the object, around the mouse, you can do this. You can turn on the move tool, go to position, advance, select the pivot object to be the mouse, and you can see now the gumball is stuck to the mouse. So now I can rotate it, keeping the mouse in the center. Okay, so you can go to your camera top view, and here you can calibrate properly which angle you should put your light source from. Okay, any question till this part? You can of course open the fourth file, which I have already configured it, so you don't need to do it from the scratch. Perfect. And if you want to create another plane, you don't have to redo all the steps. You can just right click and duplicate the part, and you get a new plane. Again, set the pivot to this object, and you can then rotate it separately. Okay, and of course in this case you will reduce the intensity of the light source so that it's not of the same intensity, so you have a bit contrastic effect. But yeah, basically you can rotate it and it's gonna create this nice composition. Locking the light to the object, you turn on the move tool, you go to the advanced tab. Pivot object is not the plane itself, but you click on this button, select the mouse, press OK, and then you can lock it to the mouse. All right. Questions? And finally, you will render it. So in order to render the scene, of course, if you want, you can add more materials. Let's say you can change this to bluish front part, this thing into something like that, maybe this into metallic parts. So yeah, you can change the colors and materials accordingly. All right, and finally, in order to render the scene, you need to first find what should be the quality of the render. First, change the lighting preset to product to have better lighting effect. It's going to take a bit longer, but the effect will be a lot better. You go to render settings, and here you have to define a couple of things. First, where you would like to save the file, what's the name of the file, and on the options tab, here you can calibrate the quality of the render. Okay, so there is this number called samples, which goes all the way from 1 to hundreds of thousands. You can set it up. But what is basically this sample parameter? Well, if you go to your viewport and go to view, turn on the heads-up display or press H, you will see that this window pops up. And whenever you reset your viewport, you will see that the sample parameter starts from 1 and then it keeps on increasing. And as it increases, you get better and better render quality. Okay, so basically what you would like to do is render a small region. Let's say this part which has a bit more shadowy area, so you have indirect lighting on that part, and you will wait till that you get a really smooth render on this part. Okay, so around 40 samples, it's looking okayish. We have some noise on the floor, but maybe by 50 or 60 samples, it's more than enough for this render. So that is the number you have to plug in this option. So you might, let's say 60 is good, so you just add maybe 5 or 10 more samples, and then you can render it. Okay, let's see what are the questions. Hi, just came in. Will you have an entry on YouTube? Yes, you can watch the recording with the same link. What was the option to lock the object? Told you. Can you add multiple shaders, bump, etc.? In this case, we are not adding any material effect. Basically, it's just a default plastic material. But yeah, technically you can get into individual materials, and then here you can add whatever you want on top of it. Okay, so let's say you want to add some kind of bump on the front part, so you get some kind of bump texture, let's say noise, and you can add that as a bump. Okay, I'm gonna exaggerate so that you can see. Will the sample continue to increase? Yes, the sample will go on and go on. Okay, but the problem is with some increment in sample you get high quality, high improvement in quality, but there will come a point where for each sample you are not even noticing the betterment. So it doesn't make sense to wait for, let's say, twice the amount of time and just get maybe 0.1% better render. Okay, so you have to calibrate it in certain part where you get pretty good result. Doesn't make sense to render it twice the length of that render time. Okay, what was about the pixel filter size? It's kind of like controlling the quality. You can see when you hover the cursor on top of the text, it explains to you level of blur applied to the image. So a value of 1 applies, no pixel blur, and maybe it goes until 3. So that applies a lot more blur. Kind of, I guess it's more or less like some kind of anti-aliasing. Yeah, so 1.5 is what you see in the real-time viewport. But yeah, you can change that. You have the same setting on the anti-aliasing quality here. Okay, you can change that as well. But yeah, generally you will only render with the maximum sample option. All right, and if you want to experiment with other file, you can also open that. And here you can see we have created a different composition. So rather than using physical lights, we are using HDRI, and you can test different HDRIs for the textures. Okay. All right. Any last questions? I cannot open the file on Keyshot 7. Yeah, unfortunately it's 10 above. The option rounded edge works well. It is working well. The only issue is that this is a really complex shape and you might crash your Keyshot window. So be careful when you apply the rounded edge. Okay. The option rounded edge, yeah, sure. All right, so let me just talk you through a quick things that some of you have been asking. One thing a lot of you asked later on is that how do I print my designs? Okay, so I have a Elegoo 3D printer, Elegoo Mars Pro. It's a SLA 3D printer, and I use G2Box slicer. So you have seen, of course, the 3D prints. I also have them here for the different textures. Okay. We have seen this texture, of course, but these two textures, they form part of the advanced texture workshop. So for the front part, I'm using a white standard resin, and for the back part, it's the texture part's the gray resin. We have online courses, so you can go to Cademy webpage and you can check our courses here. So we have Keyshot, Grasshopper, Rhino, and Advanced Grasshopper or Texture Workshop. In Rhino, if you're starting with Rhino, you want to learn how to solid model, how to match continuity, the different NURBS terminology like what is degree, what is weight, what are these G1, G0, G2 continuity criterias, how to use deformation tools, sub-D and mesh workflow. So this course might be interesting for you. We have a Grasshopper workshop. So if you are new to Grasshopper or you have basically started using Grasshopper but you don't know how the data tree works, or you're trying to follow along the tutorial but you don't truly understand what is happening, I will also encourage you to watch the previous webinars where we are doing a bit more simpler exercises rather than this complex exercise, so you might get a bit better understanding of Grasshopper. But yeah, if you're starting with Grasshopper and you feel lost, or also if you're using Grasshopper for a while but you don't understand like how it actually works, this workshop might be for you. So we'll learn the how to do basic operations like Boolean operations, fillet, but inside Grasshopper. We will create parametric models of products. We'll also learn mesh and sub-D workflow within Grasshopper and learn the concepts of a tractor, image sampler, etc. Then you have the Advanced Texture Workshop, which is basically the next step of the Grasshopper workshop and the Rhino workshop, where we specifically focus on creating textures using different strategies. Okay, of course you have the attractors. You will learn different ways to create textures using isocurve, deformation, flow along surface, particle simulation. Then you can also learn to create textures using deformation tools, voxel approach. So you will learn a really vast variety of texturing techniques, and depending upon the problem you might choose one or the other, or you can even combine a couple of these techniques together. Just keep in mind you need prior Grasshopper knowledge to join this workshop. So you have seen the triangle one in this workshop, but the hexagonal texture, which is made with a combination of multiple techniques plus kangaroo, as well as this original texture, that forms part of the Advanced Texture Workshop. Okay. And finally, you have the Keyshot Workshop, where you will learn from scratch how to create materials, configure properly physical lights, HDRI lights, animation, caustics, real cloth, these different nodes, utility nodes, which is basically like Grasshopper. You connect multiple texture properties to generate really interesting renders. And you can register on our webpage if you want more information regarding our courses. Okay. And lastly, we have also training for companies. So let's say you have your own design company, or you're like 4 or 5 designers and you would like to learn how to use Rhino or Grasshopper or advanced texture technique, you can join that. So most of our students are industrial design professionals or university students, but we also offer team training to companies and studio. So we will ask them their requirement and prepare a hybrid curriculum based upon their requirement, as well as the classes are as per your schedule. So if you want it on the weekdays, sure, why not? Keep in mind all of these workshops that I'm talking about, it's a live workshop, so I'm gonna be teaching these concepts in real time, so you can ask a question. Of course, in YouTube it's a bit difficult, but it's gonna be on Zoom, so you will be able to interact a lot better during the class. And you can check what our students are up to, so you can go to the portfolio page and you can see some of the samples. So these are basically the project file the students have to submit after they do the course to receive the certificates. So you can check out the different works from the students, and you can check our free learning resource page. So as I told you, we have past webinars. So this was let's see, this was the first webinar, which was a bit simpler one, where we created this CD player kind of thing using simple texture. So if you're starting with Rhino and Grasshopper, you can probably start with this. Then we created this trimmer. You can also download the free files from these respective web pages. And finally, the VR headset. Okay, you can download the files as well. Okay, so one last thing. If you make anything from these webinars, let's say you create your own texture, or you are trying to replicate the results, do tag us. We will really appreciate it, and we will share, of course, with our audience to boost your portfolio as well. Just look for Cademy or cademy.xyz, or also you can look for Creative Mutation if you want to tag me. All right, so I think that's basically it. Let me see if you have some additional questions, and then we are done for today. Thanks for the webinar. Thank you very much. Is the whole mouse printed or just the back part? The whole mouse was printed. So if you check the images, I have printed the entire piece. So it's gonna be a bit difficult to show you, but basically this is the base and the front part, and this is the texture part, and they come together like this. Okay, and I have done that. I have only printed one of these, but 3 of the textures separately. Okay, thank you very much, King Kasma, Carlos. Really appreciate it. Carlos has been our student. Thanks for the recommendation. Could you quickly take us through different HDRI? Okay, just a moment. What is the duration of the course? Did you even cover how to build logic? Yes, the course is around 12 hours. It's 6 hours on Sunday, 6 hours on Saturday, 6 hours on Sunday. You will have a break of 1 hour between 3 hours. And we will start from really simple fundamentals of Grasshopper, and then slowly we will build more and more complex definition. And we will also learn how to deconstruct a problem so that you can parametrically resolve it. So one example is we will be modeling this parametric torch from scratch so that you can create various variation. Let's say change the height, change the number of polygons, move the button from one place to another, etc. Okay, so yeah, you will be learning how to build a logic basically. Especially on the second day, you will learn a lot about how Grasshopper works internally, like how the data tree is created, what is longest list, how to match list hierarchy so that you can do, let's say, thousands of lofts just using one component, what is graphed, flatten, of course, and those important fundamentals so that you can later on create your script on your own. What is the duration? Perfect. Worked in ID for 4 or 5 years. Recommend Cademy to my friends. Thank you, Jay. Where can I see the pricing before the register? You can register it on our webpage, and we will send you all the information. Thank you. Thank you. Thank you very much, guys. Many blessings. Do you have any video giving perfect 3D printings? Not at the moment. We don't have a video yet, but we will definitely keep that in mind. Herman, great work. Looking forward to have more of these dedicated courses. Sure. Thank you very much. Anand, of course, thank you for joining so late in India, but Appreciate it. All right, thank you, Jose, and everyone else. Someone asked quickly about the Keyshot HDRI. Yeah, basically, you can light up your scene either by physical lights or HDRI lights. So here you can see you create, let me just turn off the depth of field. You create like a empty environment which surrounds the viewport like that. But you can also change the background color to something else, and you can add light source and move it wherever you want. If you're interested in this, you can of course sign up to our Keyshot Workshop, but we also have some of the simpler instruction on how to configure this on the past webinars, so you can check that as well. All right. What the course? If I take the course, what is the level of Rhino I can reach? So in the Rhino workshop, Rhino masterclass, you will start from really basics, and we will see a lot of complex things as we progress through the workshop. And you will of course need to do a lot of practice after the workshop, but you will be able to see a wide variety of things that you can do in Rhino, and we will be using these different examples. So one of the example I can share with you is that we will be modeling this AirPod Pro case, AirPod case, with the classes surfacing technique. So you will generate simpler single span surfaces, and then you would match the surfaces with G2 or G3 continuity criteria, right? So you will see advanced stuff like that, as well as you will also see how to use Boolean operations and how to draw curves properly in the first day. So you will see a wide variety of simpler to complex examples that will give you a good idea of what you can do with Rhino. All right, if I take blah blah blah, how can I save materials in Keyshot? It's pretty straightforward. Go to the material tab, right click, save to library, and if you want to export it, you can right click and then you can export it. Thank you, Jay. All right, so yeah, thank you very much, guys. Really appreciate it. Of course, for those of you who couldn't join, you can watch it again on YouTube with the same link. If you want to download the files, just register it on our webpage and you will be able to access the files. And yeah, if you have any questions, let us know. Write to us on Instagram or LinkedIn, or we also have a WhatsApp link on our webpage. You can ask your questions there as well. So yeah, thank you all for joining in. I'll be preparing one more webinar for probably in the coming months. So see you guys there. All right. So take care, guys, and good luck with your work and project, and stay safe and healthy. Bye-bye. Take care.